In this video, we are going to discuss about equivalent resistance of for the several circuits. So first circuit is this, and you can see all the resistance values are R. So since all are R, that is symmetrical. There are two types of symmetries are there. One is folded and mirror symmetry. So first let us apply mirror symmetry. So what is mirror symmetry means? If I draw the blue dotted line, you can see uh, you can delete this 2R, okay, and if you see the left and right hand side, both the resistance are same, right? So I can write R plus R as 2R, and this is 2R, and this one is across A and B I can write 2R, and this one is 2R, okay. So what is the equivalent resistance? R equivalent is equal to 1 divided by 2R plus 1 divided by 2R plus 1 divided by 2R. So this is, I can write it as 3 divided by 2R. So R equivalent is equal to 2R divided by 3. So this I can do it with folded symmetry also. The folded symmetry means so A and B are there. So across this one only we need to find the R equivalent. So if I draw the blue line along this A and B, for that one, for that is a folded line. So if you see, I would draw R and R, and this R, I can write it as, these two are parallel, so I can write it as R by 2, and similarly that also in parallel, so I can write it as R by 2. So this is A and B, okay, since I have folded like this in this direction. So after that I can also apply the mirror symmetry, right? So what is mirror symmetry? So if I draw the line across this R by 2, you can see R and R by 2 and R by 2 are similar. So I can remove this R by 2 value, right? So if I remove this one, R and R become series, and R by 2 and R by 2 are series. So I can write it as this one as 2R, and this one as R, right? So since 2R and R are in parallel, you can apply the formula 1 divided by R equivalent is equal to 1 divided by R plus 1 divided by 2R, that is equal to 2 plus 1 divided by 2R. So R equivalent is equal to 2R by 3. So you can see both is the same. So let me go for the second circuit. So here the potential of 1 and 1 are same, and 2 and 2 are same, right? So A is near to 1, okay. After the 2, from 2 we have a resistor, and it is connected to B, right? So you can see the diagram. Okay. Next, from 1 to 2 I have one resistor, that value is R. So R may be any value, right? R may be 4, 6, 1, 2, any values, right? So from 1 to 2 I have from 1 to 2 I have this resistor, right? So let me write it as I give it tick mark, okay. So I have drawn the 3 resistance. So you see R and R are parallel, so I can write it as R by 2. This is R, so A and B. Since these R by 2 and R are in series, I can write it as R equivalent is equal to R plus R by 2. So what is R plus R by 2? That is 2R plus R divided by 2, right? So that is equal to 3R by 2. So here there is no symmetry at all. So let us go for the fourth problem. So this is a problem. I have given the value potential of 1 1 and 2 2. Okay, so A is near to 1 and 2 is near to B, and from 1 to 2 you have one resistance, that value is R, right? That is this resistance. And another 1 to 2 I have another one more resistor, that is R. Okay, I'll give a tick mark for this one. Next you can see from 1 to 2 one more resistance is there, right? That is this one, right? So R equivalent is equal to R1 divided by R plus 1 divided by R plus 1 divided by R. Since all the three resistances are in parallel, so I can write R equivalent is equal to R divided by 3. So let me go for the fifth problem. So here I can give this is 1. So that is different, right? It is not short circuit. So I given 2, this is 3. So that point is 4. So I can see from A, 1 is near. Okay. So 1, this is 4. Okay. This is B. 4 is near to B and A is near to 1. Can give this one as 3. So from 1 to 3 I have 6 ohm as a resistor, right? From 3 to 4 I have another one resistor, that is 6, right? So from 3 to 2 you have another resistor, that is 6, and from 2 to 4 I have another resistor called 6, that is this one, and from 2 to 1 I have one more resistor, right? So now we can apply a mirror symmetry, right? Mirror symmetry or folded symmetry. So if I apply folded symmetry means you can apply both one, right? So if I apply folded symmetry, this 6 get cancelled out, right? So the folders, and if I fold like this, so 6 and 6 becomes parallel, so it is becomes 6 by 2, and here also I have 6 and 6, so it is 6 by 2, right? And so this is B. So I can 6 by 2 I can write it as 3, right? So and 3 and 3 are in series, so I can write it as equivalent resistance R equivalent is equal to 6. So next sixth problem. So here I can give this is 2 and this one is 3 and this one is 1. You can give any value, right? So this one is 1. Okay. So A is near to 3 and 1 is near to B. Okay. From so first from 3 to 2 we have one resistor, that value is 4, right? And from 3 to 2 I have another one resistor, that is this one. Okay. And from 2 to 1 I have one resistor R, and from 3 to 1 also I have one resistor, that is 4 ohm. Okay. So now it becomes easy, right? So 4 and 4 are in parallel, so you will get that one as 2. So and 2 and 4 are in series, so you will get 6, and 6 and 4 is in parallel. So but so what is so 6 into 4 divided by 10, right? 24 divided by 10, that is 12 divided by 5, right? So this is the answer.